put in. So,
Sure.
and we are live. Welcome back to Silicon Scoop, everyone. How you doing, John?
I'm doing good. How about you, Craig?
I'm doing great. Just so you know, the what we're recording now, and we're live. They'll go out. The first one will start out like February 1st. So
Okay.
that's when you start talking about dates and upcoming events later. These will come out February 1st and on.
All right.
Um, we got a lot to talk about, so we might as well jump into this first one. Meet the Antirobots, a new living entity with much to teach us. It took me a while to get my head around this. So, what do you have to say on these ones, John?
Yeah, I think they got to really work on their naming conventions because I don't think they can call it a bot, but it is a biobot. So just a quick intro. So the researchers at Tufts University, they've created what they're calling Anthrobots, which is essentially a new type of living entity, which is made from adult human lung cells out of all the cells. So these microscopic biorobots. The reason why they're calling them biorobots is because they self-assemble from a single cell and can move autonomously using cilia. So unlike previous organoids, anthrobots can interact with their environment and they exhibit various behaviors. They've actually shown some remarkable capabilities. A couple things: the ability to heal gaps in neural tissue, and when they're placed near a scratch in a layer of human neurons, the clusters can induce the neuron to grow across the gap, potentially facilitating wound healing. So really cool. But just to give you guys some background on anthrobots. So I use biorobot, but they're a new type of biological robot, which are created specifically from tracheal cells from the lung. So they can self-assemble, they can move independently. The size, they range from about 30 to 500 micrometers in diameter, so they're super, super small. They can live for about 45 to 60 days. But the biggest thing and the thing that is really cool about this, at least for now, with this new discovery, is that they can induce repair in damaged neural tissue, which is super, super cool. What do you think?
Well, I got a lot of thoughts on this, but it's both scary and cool when you start thinking about, the concept. It's a little bit unsettling, like understanding your goldfish, learning how to play card tricks. So you're because these things are, biological machines at, I won't quite say the microscopic level, but at the microscopic level, down to that cellular level. My concern is you can't control them or program them. You can only influence them. And, longer term, that seems to me like a recipe for disaster.
Yeah, so for those of you, like, we're getting into bioengineering here, right? So this is stuff that is synthetic biology, if that makes sense, guys, for those of you listening. So the thing of these things, these anthrobots, is it builds upon previous work with xenobots, which were made from frog embryo cells. So they've shown that this technology could be potentially applied to personalized medicine. But yes, it's crazy that it's scary to think of what are the long-term effects of these if we start using them. The thing is they live for 45 to 60 days. So they're not going to live forever inside of you, right? But while they're living, what other things are they going to potentially do? Or are they going to learn to do or whatever, right?
Yeah, they self-assemble and demonstrate behaviors akin to proto-organisms. They can introduce the neural cells next to them, induce the neural cells next to them to grow across the gap. So we're talking about potentially fixing spinal injuries and whatnot, which is amazing. And some of these things that we're talking about. So they're biodegradable, so they'll disappear inside the body instead of, having nanobots or machines inside you.
Yeah, these are natural, right? Or not natural, but they're organic.
Yeah.
Yeah.
And they have a wild type genome and do not exponentially reproduce, but
Yeah.
I also feel like we're
Yeah,
playing with fire with that, right? Like, are we sure that it can't like evolve or not have that and start reproducing?
yeah, and that's the thing is these entities are blurring the lines between organisms, machines, and engineered constructs, which kind of challenge our definition of life and agency. Does that would that be a fair statement, you think, Craig?
Yeah. They have their own type of intelligence. So like this is a whole new thing which um could lead to interdisciplinary breakthroughs, talking
Yeah,
about fixing stuff with the brain and the way we think and chemical interactions and stuff with the body and all sorts of things. Um, it's generally made from elderly lung tissue.
yeah,
I guess they're less likely to be rejected from the body because they're cellular tissue.
yeah. Plus,
Um,
they're the person's own cells, right? So
yeah,
there's no need for immunosuppressants at this if this actually works, or potentially.
they possess a kind of digital consciousness that allows for complex decision making in response to their surroundings.
That's scary. Like, I'm curious as like have they explored how complex their behaviors can be, or have they only scratched the surface? Do you think?
I think we're only scratching the surface, at least in the information in the papers we got a chance to look at.
Yeah.
The adaptability is crucial as we push the boundaries of what we consider life. And, you can kind of give it certain things, and as a result, it can react to certain things in the body and hopefully do repair and do the thing you want it to do. But this brings forth a Pandora's box of ethical quandaries. If anthrobots exhibit characteristics we associate with consciousness, learning, adapting, perhaps even feeling, should they have rights? And if they do, could we end up debating ethical treatment for our robot companions like we do our furry pets? Like, are we creating them to die? And that becomes a whole other issue. Yeah. Can
Yeah.
Anthrobots plead its own case to be, recharged,
Exactly.
reborn, whatever? I don't know. I mean, that seems like a far-reaching jump, but it might not be as far away as you think if we start thinking about this as intelligence and life.
Yeah, and I guess the thing is we may have to redefine what intelligence means, or come up with a new way to measure intelligence, or a new way to view intelligence, if this is the case, if this is where we're going with this. Because like there are intriguing questions about nature of life and cognition, right?
Yeah. I mean, this is if you causing me to reflect deeply on the moral fabric, and as we should as a society, as we more integrate technology into our lives, where are we blurring the lines about life, intelligence, rights? Where does the person stop and a machine begin? When you're doing things like Neuralink and all that stuff, where does the human being stop when we start going through this consciousness? So looking ahead with the implications of anthrobots, they could be profound. They might reshape industries and redefine how we interact with machines, creating new job categories and economic frameworks built on sustainability and efficiency. Thinking beyond factory floors, envision anthrobots assisting in hospitals, enhancing precision in surgery through real-time data analysis, or even transforming urban transportation with smart vehicle type systems. So this could be applied in a thousand different ways, and I'm really curious. Like, you could build something that you inject in your car engine that goes and find the leak, or finds this or finds that, and fills the hole, or does something. Like, a thousand things you can do. I know we're talking about bodily tissue, like
Yeah.
inside the human body, but there's a thousand things you could do because it reacts chemically or to the environment around it or whatever, and do the thing you programmed it to do.
Yeah. I would say that would be more like anything outside of the body would be more for nano robots, if that makes sense. I would say that would be more of a task. But who knows? Like, who knows what the limitations, or what the what these things can do as more research goes on, right?
Yeah, as we stand on the precipice of this new era of anthrobots, we must ask ourselves, if we redefine what it means to be alive, how will that change our responsibilities towards this new form of existence? Are we ready to embrace the future where technology and life intertwine, or will we just hold fast to our old definitions that might soon feel outdated? Yeah, this one was crazy.
Yeah.
Oh, yeah. Origins of life.
Oh, the origins of life. This one's crazy too.
Oops. Click the wrong button there. Give me a second. All right. Thanks for watching, all those people who are joining us. And have scientists been wrong about the origins of life? This question might sound like the premise of a sci-fi thriller, but in truth, it invites a fascinating re-examination of age-old theories surrounding how life first emerged on our planet. Today, we're diving into the rich broth of amino acid sequencing to uncover the unexpected revelations that could change everything we think we know about life's beginning. So, were we wrong, John?
It seems like we are, after doing quite a bit of research on this one and looking at multiple sources. So just to kind of get everyone up to speed on here. So researchers at the University of Arizona, the Wildcats, have proposed a significant revision to our understanding of how life originated on Earth. So in their study, what they published was challenges to the long-held consensus about the order in which amino acids, which are the building blocks of protein, emerged in early Earth conditions. So what the team did was they analyzed protein domains dating back, I don't know how they did this, but 4 billion years to what's called the last universal common ancestor of all life, or LUCA, L-U-C-A. So they used specialized software, and I couldn't find out what that software was. I wish I could, and data from the National Center for Biotechnology Information, and constructed an evolutionary tree of these protein domains. Now, their findings suggest that our current model may overemphasize the frequency of amino acids in early life forms as an indicator of their emergence order. So the thing with this is, their research actually does align with a broader trend of reevaluating fundamental assumptions about the origin of life, which makes sense because we've got this technology that's advancing. We've got AI or machine learning that can help us to reevaluate a lot of this stuff. So their research actually complements other recent studies. There was one in 2020 that suggested that life may have begun with a mix of RNA and DNA rather than just RNA alone. So I don't know what this means as far as what this is, how this affects us going forward and our understanding of going forward, and how we can use this for further research. But and again, Craig, I guess you and I have seen this. We see people who are challenging the status quo, which is great, right?
Yep. It's great to understand this all the time. And like, it's interesting. The article goes on to talk about how tryptophan appeared earlier than they thought it would, which is part of the trigger as to why they want to start reevaluating the age of all of these things.
Yeah.
So there's a lot of cool information here. And like you're saying, we're talking about proteins that date back 4 billion years. So
yeah,
it reevaluating this process could lead to understanding how amino acids formed under any Earth conditions, guiding the search for similar processes on other planets. So it could help our search for extraterrestrial life.
Exactly.
Refining our knowledge of life's origins by rethinking the sequences and emergence of amino acids, we gain deeper insights into the biochemical processes that led to life and help refine evolutionary models. So it'll help understand how we evolved and grow, and maybe lead to a more godlike complex down the road. But you know, advancing the science and technology, challenging established theories, fosters innovation in tools and methods and interdisciplinary research, dividing broader scientific progress, or driving broader scientific process. Revisiting the origins of life encourages reflection on humanity's place in the universe, offering a deeper appreciation of life's complexity and uniqueness. And, really gets us to think about, there's a lot that this discovery could lead to, and it helps out answer some profound questions about how life begins, evolves, and adapts, which are central to fields ranging from biological to astrobiology and even ethics. So there's a lot here. On the surface, you're like, okay, this is interesting, but why does it matter? And I just wanted to go through those things.
Yeah, well, yeah, essentially to make it plain and simple, it's like they're saying that life may have been more complex originally, right? So, which makes sense. Obviously, we didn't come from Adam and Eve. Sorry for those of you listening who are religious, but this is really interesting. I think what this is going to help, if they can use this to recreate a more complex evolutionary model, I think that's going to help us to understand a lot more as well. What do you think?
Absolutely. Like, they're saying that the formation of amino acids is closely tied to environmental conditions. Hypothesis suggests factors such as temperature, atmospheric composition, hydrothermal vent activity all played significant roles. Experiments simulating early Earth conditions demonstrate how these variables influence amino acid sequencing and the origin of life theories. But now that we understand these interactions better and the timing and how we can go back and evaluate all these theories, and it reshapes the discussion about evolutionary biology and how life emerged and under what conditions. So there's a lot to say here.
Yeah, there's a lot more. So I know we cover a lot of different articles, but I think in order for us to do this one proper justice, is we would have to cover do a deeper dive into other studies and bring them all together and do all that sort of stuff. So for those of you listening, this is just kind of scratching the surface, and there's going to be more that comes up, but we wanted to bring this to you because it's not just one study that's hypothesizing and coming to this conclusion. It's multiple studies, and it's cool because we're deriving away from the status quo, and we're challenging historical experimentation and historical kind of studies. And this is cool because we're learning new things, and this is great for us.
Yeah, it's always great to learn because, we need to know more about DNA and RNA and the biology and how we became and the functioning of our brain. And the more we know about the amino acids, which are the building blocks of us, the better.
Yeah.
Any final words on this, John?
No, this one's quite complex, and you and I were talking earlier about some of the complex ones that we cover, and this one's quite complex. But what's cool is amino acids. I've been learning about amino acids and how people with specific gene mutations need specific amino acids, and that's just really cool, which is why this one caught my eye, because they're talking about amino acids. So for those of you interested, you can look up gene methylation testing and have a look at those. So
yeah, the quest to unravel the mysteries of life is far from over, and it's through our relentless curiosity that we inch closer to uncovering the secrets of existence itself. So here's a thought to ponder. What if conditions that shape life on Earth are echoed elsewhere in the universe, waiting for a curious mind to decode them? Let's find that life out there, because there's not a lot of intelligent life down here. All right. Are we ready to talk about nuclear powered diamonds?
Diamond batteries. This is cool. Yeah.
Yeah, I mean, these are really cool. Let me just jump into where. Yeah. No, that's the old one. Let me go over here. Nuclear powered batteries. No, that's micro-reactors. There we go. I got the slides up. Okay. Imagine living in a world where your devices never need to be charged again. Well, hold on to your smartphones because the futuristic dream of nuclear-powered diamond batteries is edging closer to reality. 5,700-year lifespan on these.
Yeah. Crazy, right?
We are looking to, our phone to last just a couple of days.
I wish my phone even last a day.
Yeah. So we're talking about some really cool technology. Carbon 14's short range radiation safely encased in a diamond makes this battery both safe and highly durable, and sounds like incredibly expensive.
Yeah, this is cool. So I know we covered a nuclear battery in the past. Now we're talking about, this is still kind of nuclear because it's a decaying battery, but so the scientists at UK Atomic Energy Authority and University of Bristol, they've created an actual diamond battery. Now, for those of you that are like, oh, does it look like a diamond? Does it look like a crystal diamond? No. So the size of the prototype measures about 10 millimeters by 10 millimeters, which is about 4 square inches. And it's a thickness of about 0.5 millimeters or 0.02 inches. Now, it's not a single crystal diamond like those used in jewelry. It's described as a sandwich composed of thin layers made up of large polycrystalline grains. So the structure is, and you talked about this, the battery is a radioactive carbon-14 core encased in a non-radioactive diamond shell made of carbon-12. So it's made from synthetic diamond material, not natural diamond, which surprised me, but makes sense in this case, right? So like you said, it has a half-life of 5,700 years, and it generates low levels of power. Now, are you wondering, like, how does this work? So it functions similarly to solar panels, which convert light into electricity, but instead of using light particles, they capture fast-moving electrons from within the diamond structure. So that's how it creates kind of that energy. So this is cool. And Craig, I'm putting you on the spot here. Do you remember how long the nuclear battery lasted?
The one we originally talked about, I believe, was just had a half-life of 50 years.
Okay. So yeah, this is way beyond that. The thing is it does represent a significant leap in energy technology. The cool thing about this is it combines nuclear physics, material science, and energy engineering to create a power source with let's be serious. It's an unprecedented lifespan, right? So for those of you worried about nuclear radiation, the use of the diamond as a containment material, it not only ensures safety, but also allows for efficient energy harvesting from radioactive decay. So this is really cool. Craig, would you use this in your phone, knowing it's radioactive?
I wouldn't be the first one. Let me put it that way. I don't want to be near any new energy source like that and putting it up to my head. Is a whole discussion. It sounds like you're begging for trouble putting this radioactive device up to your head. So once it's out there and people have used it and aren't growing tumors, absolutely.
Yeah. Well, we're already growing tumors from RF signals, aren't we? And didn't 5G cause COVID? Sorry.
Yeah.
Sorry, guys.
But we don't know what the high ampage millimeter waves really do to the human DNA. We know it affects us, but we don't know what it does. So when you talk about, we don't really have 5G in most of us. We're not using millimeter wave signals here. So it's not, I'm saying that, until things are tested, I think I've got a skeptic hand on saying, I don't know if that's going to be healthy. I'd like to see it past all the health checks. I like to see, the independent studies rather than just somebody from the company saying, "Oh yeah, it's safe. Trust us, bro." That's
Yeah.
all. That's all I'm saying. Especially when you're talking about radiation. So
Yeah.
you sounds like you can manufacture these diamonds.
Yeah.
They don't have to be, so we can. They won't be as expensive. And I guess because the diamond actually absorbing the power is what generates the electricity or energy.
Yeah, and for those of you who are like, whoa, how much power does it produce? And so 1 gram of carbon-14 could deliver a whole whopping 15 joules of electricity per day. Now, that's less power than a standard AA battery in the short term. But if we're comparing it to, let's use an iPhone 15, for example, okay? It has a battery capacity of 46,728 joules. So 15 joules would be about 0.032% of its total capacity. So we're ways away from this being commercialized for sure.
Yeah, and the other battery we were looking at, I believe, was 5 volts. It was doing way back when. I'd have to go take a look at it.
That's a lot more than this.
But it only had 50-year lifespan. So
only 50 years. I want a day out of mine on my flip phone.
And again, I don't think it was powerful enough to run your phone all day. So it's one of those things that you'd have to think about, where does this fit? Something like this, they'll eventually get more energy out of it. They'll bring the cost down. Does this fit into, all right, we're going to start putting these things in like pacemakers so they'll never, ever run out?
Yeah. Well, I don't think that's a problem. I think they can create pacemakers that draw power from your body, I think. So I think they're going that way with that technology, but that's another discussion we can have. But yeah, there's potential advancements. Like obviously they have to increase the power output. They need to miniaturize it for more diverse applications. And who knows? The other thing that we didn't talk about is how would it influence future space exploration or deep sea research or long-term environmental monitoring, right?
Yeah, anything that you could that's hard to replace, that could be low power.
Yeah.
We're talking about that. Remember, we were talking about multi-mile range Wi-Fi that was like 100 miles range, but it was super low power, low, like these types of things where you're putting this stuff out remotely, where it's really hard to reach in the body, submerged, maybe even doing whatever they're doing with tagging of fish and wildlife, to keep that functional over a lifetime. That kind of thing becomes interesting when you start utilizing this low technology.
Absolutely. Yeah. There's like with anything that we cover, especially with how new it is, there's so many implications and so many ways that the technology could be used that we can't even fathom it for the most part, because this is such a new technology, right?
Yeah, and carbon-14 used in these batteries is extracted from graphite blocks, a byproduct of nuclear fission reactors. So by repurposing this radioactive material, the technology reduces nuclear waste while creating a valuable energy source. The UK alone holds nearly 95,000 tons of graphite blocks. So just to give you an idea. Yeah.
I didn't know that. That's crazy.
So there's a lot we could do with this if they could get that voltage up, the more than 15 joules we're getting out of it a day, because 15 joules a day is nothing.
A day, not per minute, per hour. It's per day.
So, that's what I mean. Like it's nothing. So you have to get up. You need a whole bunch of these. How big do they have to be? Yeah, I like the concept where we're going. I just not sure it's going to be in anything that we're going to use on a daily basis. But for medical devices, I believe they're going to see a lot of it.
Yeah, I agree.
We'd love to hear what you think about nuclear-powered diamond batteries, and if you want to jump on board. And I'd love to hear whether you'd be in line to buy one of these to talk nuclear powered phone and put it next to your head. Unlike me, who's gonna wait. You want to be the first? Let me know. We'd love to hear from you.
Yeah.
All right. Let me jump into this next one. Ooh, micro-reactors.
Your favorite backyard nukes. Well, not really, but
yeah. Well, similarly indeed. Let me see if I can find my notes on this. That's old. All right. So go ahead.
No, go ahead.
So Deep Fission, a nuclear startup, plans to deploy underground micro-reactors to provide power for data centers. So they're planning on burying these nukes. I call them nukes, but nuclear reactors, and providing power for data centers. We've talked about this a fair bit. What do you think about Deep Fission solution?
I think it's cool because the way that they're like what their thought process through this, right? So what they're doing is to go a little bit more into details. They're co-developing 2 gigawatts of nuclear energy. And these are supposed to be operational by 2029, which is interesting. But their approach involves placing small modular reactors in boreholes, so underground, approximately 1 mile deep. So that's pretty deep. Why they're doing that is because they're trying to leverage the natural geological advantages for enhanced safety and cost effectiveness. And what I mean by that is that the technology uses what's called mature pressurized water reactor designs, which is the most common type of nuclear reactor worldwide. So by placing these reactors deep underground, they're seeking to eliminate the need for large pressure vessels and containment structures, which are typically required for surface reactors. So the cool thing about this, right? Because having all of these containment structures and pressure vessels, that increases the cost. So by doing this, they're hoping that they could significantly reduce the cost while maintaining high safety standards. So it's really interesting. They're claiming that they can deliver zero carbon continuous power at just 5 to 7 cents per kilowatt hour, which is interesting. What do you think about that claim, Craig? Do you think they can do it?
I don't know. We'll have to see. They won't be able to do it right away. I mean, they'll do it when they have a whole bunch of these up and running. But the idea is very cool. Each one of these reactors can generate up to 20 megawatts of power, operates autonomously, and can run for a decade without refueling. 10 reactors can fit in a quarter acre, producing 150 megawatts of power. Like you mentioned, the 5 to 7 cents per kilowatt is their range. They expect to be operational in 2029. Were these reactors running for data centers?
Yeah, exactly. So they're partnered with Endeavor Energy, and so yeah, they're again, like you said, it's a major shift in how data centers supporting AI applications are going to approach their energy needs. It goes along with what we've been talking about with Microsoft and all these other big companies looking for nuclear power, right?
Yeah, and what Alberta's doing with their $7 billion with natural gas energy as an alternative to bridge the gap at a minimum. Yeah. It's really interesting. So, Deep Fission's micro-reactors are designed for deep borehole placement, enhancing safety and reducing surface footprint. They're 30-inch boreholes, like you said, that drill a mile deep. So these things aren't huge.
No. What do you think about their use for home? Because you're all about home backyard nuclear reactors. What do you think? Do you think that there's viability here?
I think there is viability here. I think what we're going to see is companies like we talked about, big AI data center companies going this route first because they can foot the bill and take the risk. And then once they see and can prove the cheap energy costs, you're going to start to see I believe it'll happen with new subdivisions first, saying, all right, we're building new subdivision. We're going to bring 1,000, 10,000 homes into here, thinking about 15-minute cities, thinking about being self-sustained, thinking about all these things. You can build power out like this and say, all right, how many gigawatts do we need to maintain the subdivision? And let's build local power. And with each of these being 20 megawatts, like big batteries, that if one goes down, the other ones keep going, you can really build redundancy in the system. I like the idea.
Yeah.
I don't know enough about this particular system, about the waste, and how it handles that, where we've seen some of that with the molten thorium salt reactors and some of the other stuff we talked about. So I'm not 100% sure where it fits on that. But we know that AI and the data centers are driving power consumption like crazy. And we all want our AI, we all want our video games, we all want our compute to do all the work we want to do. We all want to work from home. So we need our internet. So we need these things to run. And this, like, I honestly been saying this for a while, nuclear is really the only proven clean solution that gives consistent energy no matter what. So it's great to have these other ones, power and wind and whatnot. I think they've got a long way to go, especially if we can get that 90% efficiency solar cells that we were talking about before. These look great. I like this concept because I think nuclear is the future, and we're starting to see some people starting to think about that. The problem is that in people's mind, nuclear is very dangerous. So how many people died at 3 Mile Island for the meltdown?
I don't know.
Let me tell you. 0.
Oh. I didn't know that. But lots of people died at Chernobyl, which is what I think is the basis.
Well, that's another discussion. That's the numbers you think of people who died at Chernobyl are not at all what you think they are.
Interesting.
And the people at 3 Mile Island, a bunch of them got exposed to the equivalent level of radiation that you would receive if you were getting an X-ray at the doctor's office.
So then why, like, is there someone
because at the same time it happened, we got that movie China Syndrome, was it? I don't know if that's the name of it, but the big meltdown movie that scared everybody. So when it happened, everyone was fair, and we got to have all this media. It's great. Like, I mean, we need to be better. We need to be safer. I like the new solutions are much better, safer, where it doesn't have to be under pressure. It doesn't have, so if things go offline, there's no danger of things overheating or whatever. Things just take care of themselves. That is fantastic. And the newer ones that eat their own output, so the stuff that comes out just gets put back at it as input, so we don't have all this extra waste. And it's been proven. So we really need to start moving in this direction. If this particular micro-reactors are the right design, or the ones from Radiant that fit on the back of a transport truck, or any other ones that we've talked about along the way, I'm interested. I believe this is the future. The question becomes at what point do cities start adopting this and say, all right, let's build out, we want a power, we want this, we want that, it's an extra whatever investment, X billion or whatever for each of these reactors. Let's go. I imagine it's not billions for each of these, but it could be. I think the biggest hurdle though that we're facing is going to be regulatory problems, right? Well, that's the problem. They all announced doing this, and then they all got shut down by regulatory operations. Like when I say doing this, Google and OpenAI and people were announcing their Microsoft that was doing nuclear. But the one I know that is still going ahead that I know of is the Microsoft one, where they're leveraging the infrastructure of the 3 Mile Island project.
Okay,
because that's a completely different thing, and an already existing, I think they have a different regulatory, rather than, we're implementing a new nuclear on a different location, and that's a whole different versus one that already exists and is up and operational. So this is the problem, and that's why the problem is with nuclear has always been regulatory, and the government in North America changes every few years, and what the Democrats like and what the Republicans like or what have you are different things. So you don't want to invest billions into building a nuclear power plant only to have the next government come into play and say, oh, we're not doing that anymore. We're going to only go oil, or we're only going to do this or whatever. I'm not picking a side. I'm just saying from an investment point of view, it's highly risky. And that's why when Bill Gates was originally talking about this years ago, he was talking about doing it in China. And that's why I think we're seeing major investments in that thorium molten salt reactor in China. So there's a lot of this stuff, a lot of nuclear happening. And I think more and more governments are realizing that long-term sustainable nuclear is one of the only things that make sense.
Yeah.
People can argue with me and they have better I'm hoping hydrogen pulls through and can power a whole bunch of stuff so I don't have to have a nuclear reactor in my car. But hey, and let's talk about, it's funny. I don't want to get into anything untoward, but what were your thoughts on the drones that were flying over everywhere?
What do you mean?
In New Jersey and in the States, like the sedan-sized drones that were flying over and just hovering in the air for hours that people reported on.
Oh, you know what? I totally missed that. I didn't even know that. But
oh my God, really?
Yeah.
It was going on for weeks. The president we're talking about it saying the government needs to tell us what's going on. I immediately thought that these are hydrogen-powered drones. That we talked about the range and how many hours they can stay afloat and all that kind of stuff. And I'm like, wow, yeah, you really need to think. I don't know. I have no idea how you missed that. I just wanted to figure out what you thought they were powered from.
All I know is that we're so highly regulated. China's way ahead of us when it comes to drone and delivery technology.
The rest of the world is. I saw a really good interview with Mark Andreessen talking specifically about that, because we have so many regulations about range and line of sight and pilot's license that our drone manufacturers can't put in stuff to the products that the rest of the world can do. So they're jumping leaps and far bounds ahead of us. So we'll have to see whether that changes over time. But, we live in a society where people are crazy sometimes, and maybe it's a good idea to require a pilot's license if your drone is going on line of sight. But, that stifles innovation. But honestly, it stops a sky from being full of drones all the time.
It does, yeah.
So, with 6-1, I can see both sides of that particular argument, but definitely you're going to have to read up about the drones.
Yeah, I will. Yeah.
Curious to see if any information does eventually come out about what was happening.
Yeah, I'm curious to see that for sure. Yeah.
All right, let's jump into this next one. Tractor beam technology.
Yeah, this is pretty complex stuff that we're going to get into. Just a heads up. It took me a little bit to wrap my head around this, but so this is again out of MIT, which they're always coming up with crazy stuff. But we're talking not Star Trek based, but we're talking tractor beam technology that you may have heard of in Star Trek, Star Wars, all those different things. But they've developed a groundbreaking chip-based tractor beam. So it can manipulate biological particles using light. So again, it's really small. It can fit in the palm of your hand, and it uses a tightly focused beam of light that's emitted from silicon photonics chip to capture and move cells and other microscopic objects millimeters away from the chip surface, which is crazy, really cool. So it's like it's definitely an advancement over traditional optical tweezers, because those typically require bulky microscope setups. But we don't have to get into that now. But the cool thing about this, the way that it works, is it uses what's called an integrated optical phased array to generate and control the light beam. So what they've done is by creating specific phase patterns for each microscale antenna on the chip, they were able to achieve an intensely focused beam, which traps particles over a much greater distance than the previous chip-based optical tweezers, which allows them to manipulate cells while remaining in a sterile environment. So what are your thoughts on this, Craig? I'm curious to know, because I did a lot of talking here.
This is one of those things that are really cool, but it's early stages. Like, it allows precise control of cells through glass, maintaining sterility and avoiding contamination. So you can really, manipulate cells under the skin and stuff. So like it's not Star Trek, let's grab a ship out of the thing and stop it from moving away, but it is coming close to telekinesis.
It is, yeah, because you're going to have like you said, the ability to manipulate cells and other biological particles without direct contact. So
yeah, the beam manipulates particles millimeters away from the chip surface. The device uses you mentioned all that.
Yeah, it could be used in diagnostic tools for more efficient cell sorting and analysis. It could be used in minimally invasive procedures, allowing for manipulation of cells or even drug delivery vehicles within the body. I know the other one we were talking about, the Antirobots, those could also be used for drug delivery as well. But yeah, so there's a lot of different implications for this technology. But again, we cover things that are so new, like that yeah, there's so much more to be discovered, right?
Yeah, I mean, right now the device is small enough to fit in the palm of your hand. The device enables optical trapping and tweezing without a complicated bulk optical setup. Like, I would imagine that if it was cheap enough, people would start using this for tweezers. Never mind, because once you start, you don't necessarily have to be invasive and whatnot. But this, like, it's really cool. We're on leading edge. If they can fit, like I said, if they can fit this in the palm of your hand now, what's it going to be like in 10 years?
Exactly. Yeah.
If we're moving these things, millimeters thickness, so now we can typical steroid glass cover slips are about 150 microns thick. So this thing will penetrate that. So now you can manipulate stuff inside the glass, inside the test tube. This is great for studying DNA, classifying cells, investigating disease mechanisms without, possible ability of infection or whatnot. It's amazing where we've come from. Like, I like where this is, and I would extrapolate farther that it wouldn't be long, I believe, that we would be able to manipulate things that are much farther away.
Yes. Yeah, it's just they just have to work on the antenna technology and the chip technology, right?
Absolutely. And when you can use light to manipulate things, you start to wonder about the physicality of light.
Yes.
So I just, because
it brings up so many other questions, so many other like things that we haven't even thought of, right? And yeah, it's crazy, it's scary, but it's interesting.
Absolutely. And we don't think about the physicality of light because it's just there. It doesn't hit us, but we can feel it, we can see it, but but that now you can use light to manipulate objects and physically move them. You're like, wow, that becomes different. Our perception changes on all of these things. But I guess laser is light too, right? So it can really do damage and do other things. Would really like to know what you think where this is going. Tractor beam technology, are we going to see telekinesis tools? Are we going to see other very cool, interesting tractor beam technology tools in the future? Let us know.
Yeah.
All right, we got one more. So we talked about this a while ago. The FTC has come down on Google suggesting they need to sell Chrome to demonopolize them, and Google went away and said, let us think about that. And they've now come back with a proposal saying, let's not sell Chrome, let's do these other things.
Yeah.
So they've put that proposal to the FTC. And the court hearing to talk about it further is April 2025. So have you read through what their proposal is?
Well, it kind of. I read through it on a high level. So the thing is in their proposal, they disagree with the ruling.
Yeah,
first
of course.
Right? But they suggest ways to make it so they're doing things that are it's just a joke. So they're suggesting ways to make its contracts with browser companies and Android device makers more flexible. They're looking to allow browser companies like Apple and Mozilla to continue offering Google search, surprise, surprise, while earning revenue from the partnership. The other proposal is it would enable these companies to have multiple default agreements across different platforms and change their default search provider every 12 months. Like, I don't get it. The other thing is for device makers, Google is proposing that there's additional flexibility in preloading multiple search engines and Google apps independently of search or Chrome. So, again, it's like, what are your thoughts on those things, Craig? Like,
well, let me just go through a few more points here. Google suggests a non-exclusive search agreement with device manufacturers to address antitrust concerns. You talked about that. The annual default search engine changes. You talked about that. DOJ previously recommended divesting of Chrome. Google's proposal aims to maintain revenue sharing agreements with the browser developers like Mozilla. This is the one thing I do like, because my biggest problem was when you take those agreements away, Mozilla disappears, because 89% or 91% of the revenue comes from Google search. Apple has backed Google on this because they want to continue their $20 billion a year revenue they get from Google by using Google as the default search in Apple. Is that a good thing? Is that a bad thing? They say that breaking it up will stifle innovation. And we've talked about this before. Unless Google is actually stifling innovation, them putting more money in open sourcing all this seems to advance the technology versus hold it back.
Yeah.
But they are a monopoly in search. So, I'm not, I think we can probably decouple the Chrome situation from the search situation.
I think so.
And I think that's what they're trying to do here. Like, I honestly don't believe it's necessary for them to sell Chrome, but it's necessary for them to have some different search policies around this stuff that meet
well,
better.
The thing is, like, I know there's Search GPT that's coming up. I know there's Perplexity. But up until those two came out, like, there really wasn't a good search. Bing was horrible. I've never used DuckDuckGo. I don't know if you used it, but
and it's based on Bing.
Okay. So, like, there really isn't a good alternative to Google if you're looking for relevant results. Up until they messed around with their algorithm. But since we covered this as well, now they've integrated Gemini into the search results. So instead of giving you sites right away, it gives you kind of a summary, or more of a summary of what you're searching for I don't know. What are your, do you think this is going to open the door for search engines or not search engines, but search solutions like Perplexity and GPT search? Or what do you think, Craig?
I think the world is changing at a more dramatic rate than people realize.
Yeah.
I'm doing AI and automation tools every day. And like the last week alone, I've seen 3 or 4 or 5 AI tools that replace search for automation locally. And like, Google's on the way out. The problem becomes is most of the search tools still require a tool like Google that have done the web crawling, that done the base level, because we on our individual machines can't crawl the internet as a whole and stay up to date on all that. So the role of these companies are going to change. And we'll have to see whether everyone else does the same thing, and so that they all have their own databases. But Google controls DNS. They control so many different things. It's hard to take them out of search, which is the problem, I think, overall. But I like more competition. I think Google has not been good with the search results. They give you the right ads, but the search results aren't great. I think they're screwing themselves over with the Gemini stuff. They seem to have a policy of trying to keep you on Google's pages now versus sending you off. Which, their value is links and selling ads. But if you're trying to keep people on your platform, then what are you selling? So I think they have to be very careful as to where their future and where their revenue is going to come from, because it does seem, except for the ads, they want to keep you on the platform. Here, we'll say, here's a thing, you can just copy and paste this and give us your next search, or we'll serve up more information. But you're right, until like 6 months ago, they didn't have a lot of competition. But now that AI is taken over, we search GGP, Perplexity, SERP API, a bunch of different tools out there that allow you to pull. I think SERP API is a Google tool, but there's a bunch of them out there that allow you to do these things either through tools or through a front end, or hook them up as your default search engine. And I think the world is changing. I think
so.
I think we won't be searching nearly as much manually as we used to. I think we're going to be giving that over to AI agents by the end of the year, and we won't be defaulting to a chat GTP default or a Perplexity default. We'll have our own agents that know our own what we do, our likes, our dislikes, and we'll go out and find the stuff. So I that's all I think is going to change. And had this been happening 2 years ago, I would have been right on them. I just think I'm not sure if this is going to get anywhere.
Or what impact it'll have if it goes somewhere, right?
And I there's things that they should be done, but I'm fairly certain we're going to get a lot of the stuff that hurts the industry and less of the stuff that helps the industry. That's usually what happens in these things. So let us know what you think about this FTC alternatives that Google proposed, and what do you think is going to happen in April 2025. We'll keep on top of it and get back to you when there's more updates for sure. So what do you got going on, John?
I don't know. When's Startup Drinks in February? Do we have a date?
I don't have a date yet, but it'll be probably the third week.
Third week of February, don't have much in February. I'll be at TBDC for a day doing a lunch and learn, but that's about it. What about you?
I've got lots of stuff. We've got a workshop planned, but the dates aren't finalized. So take a look at torontostarts.com and follow us there. On our next couple of podcasts, we'll have better updates on to the dates for the year. I just haven't got them all scheduled in like I normally do. And we're doing workshops, we're doing online webinars, we're doing discovery calls. So check out startupcoach.ca if you're stuck in your business, or if you want to talk about what automation and AI and how it can help you. Book a discovery call there and let's talk about it. And if you want, people want non-dilutive funding, John, where do they go?
Reach out to me, find me on LinkedIn. My website will be up soon, so you can find me on the website. But for now, just find me, John Irwin, on LinkedIn.
And thanks, everyone, for watching today. Appreciate it.
Thanks, everyone.